Solve x is less than or equal to 12 over x plus 1. Answer in interval notation. So we're going to start here by moving all the terms over to one side. I'm going to move the right-hand term over to the left side by subtracting it from both sides. So I'm going to get x minus 12 over x plus 1 is less than or equal to 0. At this point, we're going to be putting the two terms on a common division line. So we need a lowest common denominator, which here is going to be x plus 1. So this will allow us to put this on a common division line. The first term becomes x times x plus 1 minus 12 divided by x plus 1 is less than or equal to 0. Now we can expand the numerator. We're going to get x squared plus x equals to, or minus 12 over x plus 1 is less than or equal to 0. Now, the numerator is a trinomial where the coefficient in front of the x squared term, a, equals to 1, which means that we can try and factor this using the method of inspection. And so there are two numbers we're looking for that multiply to negative 12 and they add to positive 1. Those two numbers are negative 3 and 4. So we can factor this out into x minus 3 times x plus 4 over x plus 1 is less than or equal to 0. Now at this point, what we want to do is we want to find the critical values. So we want to find the critical values, which means that the function f of x equals to 0, and this will happen when x equals to positive 3 and when x equals to negative 4. Now we also want to note that in the denominator there will be a non-permissible value where x cannot equal to negative 1. So that's going to be another one of the critical values. We're going to say that x cannot equal to, should be negative 1. Sorry about that. Negative 1. Okay. Now we're going to determine the intervals when the left-hand side, this rational expression, is less than or equal to 0, and we're going to do that by using a number line. Let's see, I'm going to go in black instead, like that. We're going to put in the critical values. So negative 4 is over here, negative 1 is over here, and 3 is over here. And then we're going to analyze the signs of the different factors that we have in this rational expression. Okay, so we have 4 intervals. Let's start with this first interval here. What we also should do, actually, we should put in whether we include these points or not. We're not including negative 1 because it cannot equal to negative 1. We are including negative 4. So it's a solid dot. And we're including positive 3. So now we can look at this interval right here. So x is less than negative 4. When x is less than negative 4, this first factor will be negative. A negative number minus a negative minus another number will be negative. So it's negative. The second factor, x plus 4, will also be negative. Divided by x plus 1. Well, if x is less than negative 4, that means the denominator will also be negative. Negative times negative is positive. Divided by negative is negative. So when x is less than negative 4, this entire expression is negative. And so this interval in yellow will be part of the solution, because it is less than 0. Second interval between negative 4 and negative 1. The first factor here will be negative. The second factor, x plus 4, is going to be positive when x is between negative 4 and negative 1. And the denominator will be negative. That means that between these two critical values, this rational expression will be positive. Negative times positive is negative. Negative divided by negative is positive. For the next interval from negative 1 to positive 3, the first factor here, x minus 3, is going to be negative. The second factor, x plus 4, is going to be positive. And the denominator, x plus 1, is going to be positive. Negative times positive is negative. Negative divided by positive is negative. So this interval here between negative 1 and 3 is also included because it is less than 0. And then the last interval here, when x is greater than 3, when that happens, all factors will be positive and the entire quotient, the entire rational expression will be positive. So that's not going to be included in the solution. We want to express the solution in interval notation. So it's a union of these two intervals. So we're going from negative infinity up to negative 4. We are including negative 4. Union. And then we go from negative 1, not including negative 1, up to 3, including 3.